We talked about the factorizing method last time. It's really useful and really simple to solve quadratic equations. But this lesson, we're going to cover an even more commonly used technique. Let's just start with a simple one. X squared equals 4. So what's the value of x? You see, it seems quite easy. X equals 2 because 2 to the power of 2 is 4. But think of another solution of it. Minus 2 times minus 2 is also 4, right? So we could take x equals minus 2 as another solution. And then let's go further. So x minus 1 squared equals 4. And how to solve this? You can view x minus 1 as an integrity. You take it as a whole variable, as a whole unknown, t. And so you can see t equals minus 2 or 2, which means x minus 1 equals 2 or x equals 1 equals minus 2. And the key is you take it as an integrity. And so the solution of it will be x equals 3 or x equals minus 1. And we could even go further. 2x minus 1 squared equals 4. And how to solve this? You can still take 2x minus 1 as an integrity, so it equals 2 or minus 2. So x would equal 1.5 or 0.5, but negative. So after expanding those brackets, well, actually we don't literally factorize it, don't expand the bracket, we just do a third on both sides, and that's how we take the power of 2 away. But think of it, can we use this way into a normal form of quadratic formula? So next time, given you a general form like this, maybe we'll have an idea of turning it into the squared form to solve it. If we can rewrite it into this form, let me just do the result for you. It will seem easy to solve this. So x minus 1 equals 2, or x minus 1 equals minus 2, x is 3, or x is minus 1. You've learned how to factorize before, and now you need to learn how to turn this into the quadratic form, and this will be your main job. But how do we do this? Well, first you should know this method is called completing the square. It's just like mixing ingredients in a recipe. We complete the equation into a perfect square. And now let's look at the example before. X minus 2x minus 3 equals 0 and review it. We could solve it by factorizing into x minus 1 times x plus 1 times x minus 3 0. So x will be negative 1 or x will be 3. So this is the way we solved it before. But how do we convert it into the squared form? Let's just start it with a more simple expression, x squared minus 2x. And how to write this as a perfect square? You could observe it from another equation, x minus 1 squared. You see how to expand the bracket. Well, it's x minus 1 times x minus 1 and expand the bracket. You should be very used to this. So after expanding it, it will be x squared minus 2x plus 1. And then you could compare them. You see, if you're trying to rewrite x squared minus 2x into the squared form, you're missing 1, or you just need this number. So I think maybe we could plus 1 and minus 1. Plus 1 and minus 1. So you see, this part can be converted into x minus 1 squared minus 1. And we solve it by observing it from another equation. And then let me do another one for you, x squared minus 4x. And how to do it like the perfect square here. Well, you need to observe, you see, this -1 corresponds to -2 here, because it's a doubles time here. And I could think it from the opposite direction, so maybe it's something related to x minus 2 squared. Anyways, then let me just expand it. So it's x squared minus 4x plus 4. Oh, it seems that they're connected. So I could just plus 4 and minus 4. And then this is a perfect square that I'm looking for. So it's x squared, x plus 2 squared minus 4. And let me try another one. X squared minus 6x. How do I turn this into the squared form? Still, you see, plus 2 corresponds to, oh, I think this is minus 2. I take it wrong. You see, minus 2 here corresponds to minus 4x. So it's their doubling relationship. And I suppose it will be x minus 3 squared. So let me just try to expand this. X squared minus 2x plus 9. So you see, they have the same part. And all I need to do is just plus 9 and minus 9. And then this occurs again. And I can rewrite this into the squared form, x plus 3 squared minus 9. And so this is a method called completing the square. And you should try another one with a blank area, x squared minus 2x. So here is a trick. You see, it's minus 8. So something inside the bracket, it must be 4, because they have the doubling relationship. And after 4 is expanded, there will be a 4 squared in and out. So I can just replenish it. X squared minus 2x plus a 4 squared and minus 4 squared. So here they have a perfect squared relationship. So x minus 4 squared minus 4 squared, or minus 16. And let's do another one. X squared minus 10x, still something inside the bracket could be 5. And all I need to do is just plus 5 squared and minus 5 squared, and this part would be the perfect square. So it will be x minus 5 squared minus 25. And in general, x squared minus 2a times x compared with x minus a squared, all I need to do is plus a squared and minus a squared. So this part in the middle can be rewritten into x minus a squared minus a squared. And that's basically how we factorize. No, that's basically how we do the complete the square method of solving quadratic equations. And let's just get to one practical question. So x minus 2x minus 3 equals 0. Well, first you can just neglect this part. Do not care about the constant here. Just focus on this part, because all we need to do is to change it into the quadratic form. And focusing on this part, I think we need 1 here. X minus 2x plus 1 squared and minus 1 squared minus 3, 0. And something in the middle could be rewrite as x minus 1 squared equals 4. So it's x minus 1 is 2, or x minus 1 is negative 2, so x would be 3 or minus 1. So if you have got used to this, congratulations, have mastered the second method of solving quadratic equations called completing the square. And let's do another one. X squared minus 4x minus 5 equals 0. And just focus on the first part, minus 4x. We need a 2 squared and minus 2 squared and minus 5. So this part can be rewritten as x minus 2 squared equals, and let me just remove the two constants into the right side, equals 2 squared plus 5, which is 9. So x minus 2 would be, you will this as an integrity, so it will be positive 3 or negative 3. So the value of x will be 5 or minus 1. So we've now learned two more methods for solving quadratics. The first one is by factorizing, and the second is completing the square. Both can solve these classic examples. And we will also learn a third method next time called quadratic formula, a handy memorized formula, but we will also explain where it comes from. And that's it for this lesson. If something wasn't clear, go back and review the parts that need more attention. This completing the square method will come up again later when graphing and even when solving higher level equations like logarithmic or exponential ones, because we often return them into quadratic ideas. We can also understand completing the square visually with area. Imagine x squared plus ax. So x is the square size of zx. Let me just give you a square. And for ax, it's just another two sides of the equation. So here is 2a and 2a. So its side is still a, but its length is 1/2 a. And this is exactly the area on the red figure. And if I'm trying to combine them into a square again, I need to cover this area, which is a over 2 squared, and I just need to plus this green area and minus it because I'm just making it up. It doesn't really exist. And this part would be the area of the yellow square, which would be x plus a over 2 squared and minus the green area, 1 a over 2 squared. So this is visually how you solve this, by doing area. And that's the geometry idea behind completing the square. And we wish you can learn something from this class, and see you next time.